Imagine diving deep into an ancient ocean, a world so different from our own, it might as well be another planet. The water is murky, filled with strange and wonderful creatures. Suddenly, you see something glide past. It looks like a shark, but it has something truly bizarre. A spinning wheel of teeth sits right in its lower jaw. This isn't a monster from a science fiction movie, this was a real animal. It was called Helicoprion, the buzzsaw shark. For over a century, this creature was one of paleontology's greatest puzzles. Its fossils left scientists scratching their heads, wondering how such a strange tool could even exist. It's a story of discovery, mystery, and incredible scientific detective work. The first thing you notice about Helicoprion is that spiral of teeth. It's unlike anything alive today. No other animal, living or extinct, has a feature quite like it. This tooth whorl looks like a circular saw blade made of razor-sharp daggers. When the first fossils were found, scientists didn't know what to make of them. Was it a weapon on its tail, a defensive coil on its back, or something even stranger? The mystery of the tooth whorl captivated imaginations and challenged everything we thought we knew about ancient marine life. Exploring the story of Helicoprion is like going on an adventure back in time, piecing together a creature that defies all expectations and reveals the incredible creativity of evolution. This animal is a testament to how wild and weird life on Earth can be. We often think of sharks as perfect predators, unchanged for millions of years. But Helicoprion shows us that their family tree is full of incredible experiments. It was a fish that took a completely different path. Finding just the fossilized tooth whorls was like finding a single, mysterious gear from a complex machine. Scientists had to work backward, using clues from the fossils and knowledge of modern sharks to rebuild the entire animal. It's a journey that takes us from dusty museum collections to cutting-edge laboratories, all in the quest to understand this amazing predator from a lost world. Getting to know Helicoprion is more than just learning about an old fish. It's about appreciating the sheer wonder of our planet's history. It reminds us that the world has been home to countless life forms, each with its own unique story of survival. The buzzsaw shark is a perfect ambassador for this ancient past. Its strange appearance grabs our attention and invites us to ask questions. How did it live? What did it eat? And why is it gone? Answering these questions helps us connect with a time long before humans walked the earth, and it shows us just how much there is still left to discover about the history of life. To understand Helicoprion, we have to travel way back in time. I mean, way back. We're talking about the Permian period, which lasted from about 299 to 251 million years ago. This was long before the first dinosaurs ever stomped the Earth. The world was a very different place. The continents as we know them didn't exist. Instead, most of the planet's land was fused together into one massive supercontinent called Pangaea. This created a single gigantic ocean known as Panthalassa. It was in this vast ancient sea that Helicoprion reigned as one of the top predators. It was a true king of a forgotten world. The environment of the Permian oceans was teeming with life, but it wasn't the same life we see today. The reefs were built by different kinds of sponges and corals. The waters were filled with ammonites, which were shelled relatives of modern squid and octopuses. There were also vast schools of ancient fish and other strange sea creatures. Helicoprion swam through these waters, a formidable hunter in a complex and thriving ecosystem. It lived for an incredibly long time, surviving for millions of years and adapting to a changing world. This wasn't a short-lived experiment. Helicoprion was a successful and enduring lineage of predator, a true survivor of its time. The climate during the Permian was also quite different. It started out relatively cool and dry, but it gradually warmed up over millions of years. This had a huge impact on life, both on land and in the sea. Helicoprion's long existence means it witnessed these massive environmental shifts. It adapted and survived through changing ocean temperatures and shifting food webs. Finding Helicoprion fossils in places as far apart as Idaho, Russia, and Australia tells us that it was a widespread and successful animal. It wasn't confined to one small corner of the globe, it was a citizen of the great world ocean, Panthalassa. This ancient setting is what makes Helicoprion so fascinating. It wasn't just a weird fish, it was a weird fish in a weird world. It was a product of a unique time in Earth's history, a time of giants and strange evolutionary experiments. When you think about Helicoprion, don't just picture the animal. Picture the world it lived in. Picture the single massive continent, the vast global ocean, and the other strange creatures it shared its home with. It's a window into a chapter of Earth's story that is as dramatic and compelling as any tale of dinosaurs, and Helicoprion was one of its biggest stars. The story of Helicoprion science begins in the late 1800s. Miners and fossil hunters started finding these strange, spiral-shaped objects in rocks in the Ural Mountains of Russia. They looked like tightly coiled ammonite shells, but they were made of teeth. In 1899, a Russian geologist named Alexander Karpinsky was the first to study and name this creature. He called it Helicoprion, which means spiral saw, but he had a huge problem. He only had the tooth whorl. The rest of the animal's body, which was made of cartilage like modern sharks, hadn't fossilized. So, where did this bizarre spiral of teeth belong? This question kicked off a scientific debate that would last for more than 100 years. Karpinsky's first guess was that the tooth whorl was a weapon coiled on the animal's snout, like a curled-up trunk. Other scientists had different, equally creative ideas. Some thought it was a defensive weapon attached to the dorsal fin on its back, spinning around to ward off attackers. Another wild theory suggested it was part of the tail fin, used to slash at prey. For decades, illustrations of Helicoprion showed it with this tooth whorl in all sorts of strange places. These early drawings look almost comical to us now, but they represent the best guesses scientists could make with the limited evidence they had. It was a genuine paleontological mystery. As more fossils were discovered around the world, from the remote mountains of Idaho to the plains of Australia, scientists got more examples to study. But they were always the same, just the isolated tooth whorls. No skull, no fins, no spine. It was incredibly frustrating. The animal was literally a puzzle with only one very strange piece. One popular idea that lasted for a long time was that the whorl sat at the very tip of the lower jaw, hanging down like a strange circular beard of teeth. This was a step in the right direction, but it still didn't quite make sense. How would the animal even close its mouth? The debate raged on through the 20th century. Every new fossil discovery was scrutinized for clues. Scientists analyzed the shape of the teeth, the way they were worn down, and the structure of the spiral itself. They knew the teeth were being used for something, but without knowing where they were located, it was impossible to say how. The mystery of Helicoprion became famous in paleontological circles. It was a classic example of how difficult it can be to reconstruct an animal from incomplete remains. The buzzsaw shark kept its secrets well hidden, waiting for a time when technology could finally unlock its puzzle. Let's take a closer look at that incredible tooth whorl. It wasn't just a random jumble of teeth, it was a highly organized, continuously growing structure. Think of it like a conveyor belt of teeth. As the animal grew, new, larger teeth would form at the back of its jaw. Instead of the old teeth falling out like they do in modern sharks, they were pushed forward and down into the center of the spiral. The oldest, smallest teeth from when the animal was just a juvenile were tucked away deep inside the coil. This means a single Helicoprion tooth whorl is a complete record of the animal's life, from its youth to its adulthood. The teeth themselves were serrated and triangular, like a steak knife. They were clearly designed for slicing. The largest teeth on the outer edge of the whorl could be several inches long. A full large whorl could be over 2 feet in diameter and contain more than 150 teeth. This wasn't a delicate structure, it was a powerful and formidable weapon. The way the teeth are arranged in a perfect logarithmic spiral, the same kind of spiral you see in a nautilus shell or a galaxy, is a beautiful example of natural engineering. It's a mathematically precise killing machine, honed by millions of years of evolution. One of the big questions was how this whorl actually worked. Since the teeth were preserved in a tight spiral, many scientists initially thought the whole structure might have spun freely like a mechanical buzzsaw. This idea, while exciting, was biologically impossible. The whorl was fused to the lower jaw cartilage. It didn't spin. Instead, the jaw's movement would have brought the teeth into action. When Helicoprion closed its mouth, the whorl would have rotated backward, slicing its prey against the upper jaw. It was a cutting mechanism, using the power of the jaw to pull food through a series of sharp blades. This unique dental system highlights what a specialized predator Helicoprion was. Unlike a great white shark, which can grab and tear large chunks of flesh, Helicoprion was built for a different kind of hunting. Its tooth whorl was a tool designed for a specific purpose, likely for processing soft-bodied prey. The continuous growth of the whorl also meant that it always had a fresh, sharp set of cutting teeth ready for action. It never had to worry about losing a tooth and having a gap in its bite. It was a perfectly efficient, self-renewing weapon, one of the most remarkable dental adaptations in the history of life on Earth. For over a century, the mystery of the Helicoprion tooth whorl was stuck. Scientists were arguing in circles, limited by the fossils they had. Then, in the 21st century, everything changed. The breakthrough came from a team of researchers led by Leif Tapanila at Idaho State University. They had access to an exceptional fossil from Idaho known as IMNH 37899. This fossil was special because for the first time, the tooth whorl was preserved inside the rock, surrounded by faint impressions of the jaw cartilage. It wasn't just a whorl, it was a whorl in context, but the cartilage was too faint to see clearly with the naked eye. To see what was hidden in the rock, the team turned to cutting-edge technology. They used a high-resolution CT scanner, the same kind of machine used in hospitals to look inside the human body. The scanner took thousands of X-ray images of the fossil from every angle. These images were then fed into a powerful computer, which created a detailed three-dimensional digital model of the fossil. For the first time, scientists could virtually peel away the layers of rock and see the delicate jaw structures that had been hidden for 270 million years. The mystery was about to be solved. The digital model revealed the truth, and it was amazing. The tooth whorl was not on the nose, the back, or hanging from the chin. It sat deep inside the mouth, filling the entire back of the lower jaw. The spiral was braced by the jaw cartilages on both sides. This position finally made sense of how the animal could open and close its mouth. There was no upper set of teeth directly opposing the whorl. Instead, the whorl would have sliced prey against the smooth cartilage of the upper jaw, like a knife on a cutting board. The mystery that had puzzled scientists for 114 years was finally solved with this incredible technology. This discovery also revealed something else profound about Helicoprion. It wasn't a shark. The CT scans showed that its skull structure, particularly the way the upper jaw was fused to the brain case, was different from true sharks. Instead, Helicoprion belonged to a more ancient group of cartilaginous fish, called the Eugeniodontida. These are distant relatives of modern ratfish, or chimeras. So, the buzzsaw shark wasn't a shark at all. It was something much older and stranger. This revelation completely rewrote our understanding of this animal, proving how modern technology can shed new light on ancient fossils. With the tooth whorl puzzle solved, scientists could finally create an accurate picture of what Helicoprion looked like. It wasn't the monster with a saw on its nose from the old drawings. Instead, it was a sleek, powerful, and honestly, a very strange-looking fish. Based on the size of the largest tooth whorls, which reached over 2 feet in diameter, scientists estimate that a big Helicoprion could grow up to 25 feet long. That's, actually bigger than a modern great white shark. It was definitely one of the largest predators in the Permian seas, and it would have been an awe-inspiring sight to behold. Instead of the typical shark-like snout, Helicoprion had a short, blunt head. Its upper jaw was fused to its skull, and its lower jaw was filled with that incredible tooth whorl. It likely had large eyes to spot prey in the murky depths of the Panthalassan Ocean. Its body was probably long and torpedo-shaped, built for efficient swimming over long distances. Like its modern relatives, the chimeras, it likely had large pectoral fins that it used to fly through the water. It probably didn't have the classic dorsal fin we associate with sharks, giving it a more eel-like or streamlined profile in the water. The skin of Helicoprion was probably smooth, lacking the rough, tooth-like scales or denticles found on modern sharks. This is another feature it shares with its chimera relatives. This smooth skin would have reduced drag, helping it glide effortlessly through the ocean in search of its next meal. Its coloration is a mystery, but like many large ocean predators today, it may have had countershading, a dark back to blend in with the deep water below, and a light belly to blend in with the bright surface above. This would have made it a stealthy and effective ambush predator. Putting all these pieces together, we get a portrait of a truly unique animal. It had the size of a great white, the body of an ancient chimera, and a mouth unlike anything else in history. It was a highly specialized hunter, perfectly adapted to its environment and its specific diet. The journey from a single mysterious fossil to a full-body reconstruction is, honestly, a triumph of science. It shows how, with patience, persistence, and the right tools, we can bring these incredible creatures back to life, at least in our imaginations, and give them their rightful place in the story of our planet. Now that we know what Helicoprion looked like and how its jaw worked, we can make some really good guesses about what it ate. That buzzsaw jaw was a specialized tool, and specialized tools are used for specific jobs. The slicing, backward-pulling motion of the tooth whorl wouldn't have been very effective against hard-shelled animals. Trying to crush a shell with that mechanism would be like trying to hammer a nail with a saw. It just wouldn't work well and would likely damage the teeth. This tells us that Helicoprion was probably a specialist hunter of soft-bodied prey. So what was on the menu? The Permian oceans were full of perfect targets. One of the most likely food sources was ammonites, ancient relatives of squid that had shells. But wait, didn't I just say it didn't eat hard-shelled things? Well, the idea is that Helicoprion didn't crush the shells. Instead, it might have used its tooth whorl as a kind of can opener, snagging the soft body of the ammonite and pulling it out of its shell. Other scientists believe it focused on prey that had no shells at all, like ancient squid, octopuses, and jellyfish-like creatures. The whorl would have been perfect for slicing through these soft, slippery animals. The wear patterns on the fossilized teeth support this idea. Scientists have found teeth that are broken or worn down, but not in a way that suggests they were consistently crunching hard bone or shell. The damage is more consistent with processing soft but slippery food. Imagine a giant squid trying to get away. Helicoprion could bite down, and as it closed its mouth, the rotating whorl would pull the squid further in and slice it into manageable pieces. It was an incredibly efficient system for dealing with the kind of prey that might otherwise slip away. It was the ultimate calamari slicer. As one of the largest predators of its time, Helicoprion played a crucial role in its ecosystem. It was an apex predator, sitting at the top of the food chain. By keeping populations of squid and other cephalopods in check, it would have helped maintain the balance of the entire ocean food web. The existence of such a large, specialized predator tells us that the Permian seas were healthy and productive, able to support a huge animal that needed a lot of food to survive. Helicoprion wasn't just a weirdo, it was a sign of a thriving and complex marine world. Helicoprion was a huge success story. This lineage of fish survived for nearly 40 million years, which is honestly an incredibly long time. They swam the world's oceans, adapted to changing climates, and dominated the food chain. But even the most successful creatures can't survive everything. Helicoprion's long reign came to a dramatic and catastrophic end about 252 million years ago. This was the end of the Permian period, and it was marked by the single largest mass extinction event in Earth's history. It's known as the Permian-Triassic extinction, or more dramatically, the Great Dying. This wasn't a slow decline, it was a global catastrophe on an unimaginable scale. Scientists believe the extinction was caused by massive volcanic eruptions in what is now Siberia. For thousands of years, volcanoes poured out enormous amounts of lava, covering an area larger than Western Europe. These eruptions also released colossal amounts of greenhouse gases like carbon dioxide and methane into the atmosphere. This triggered runaway global warming, causing temperatures on land and in the sea to skyrocket. It was a planet-wide disaster from which life almost didn't recover. The oceans were hit especially hard. As temperatures rose, the water lost its ability to hold oxygen, creating vast dead zones where most marine animals couldn't breathe. The massive amounts of carbon dioxide in the atmosphere also dissolved into the seawater, causing ocean acidification. This made it difficult for animals with calcium carbonate shells like ammonites and corals to survive. The entire marine food web collapsed. The reefs died, the prey disappeared, and the predators, no matter how big or powerful, starved. For a specialist hunter like Helicoprion, the loss of its soft-bodied prey was a death sentence. Helicoprion, along with up to 96% of all marine species and 70% of all land animals, went extinct. It was a complete reset for life on Earth. The buzz-saw shark, which had survived for millions of years, simply couldn't adapt to such a rapid and devastating environmental collapse. Its disappearance marks the end of an entire chapter in the history of life. When the world finally began to recover in the following Triassic period, new kinds of predators like the ichthyosaurs rose to take its place. The age of the buzzsaw sharks was over forever. Even though Helicoprion has been extinct for over 250 million years, its legacy is more powerful today than ever before. For scientists, it's a perfect case study in paleontological problem-solving. The The story of how we went from a mysterious spiral fossil to a full, accurate reconstruction shows the power of the scientific method. It's a tale of observation, hypothesis, debate, and finally, discovery through new technology. Helicoprion teaches us to be humble and to keep asking questions even when the answers seem impossible to find. It reminds us that there are still incredible secrets locked away in stone, waiting for the right tools and the right minds to uncover them. Beyond the lab, Helicoprion has captured the public's imagination. Let's be honest, a prehistoric shark with a buzzsaw in its mouth is just plain cool. It has become a celebrity of the fossil world, starring in documentaries, museum exhibits, and books. It sparks curiosity, especially in kids. When a young person sees a picture of Helicoprion, it opens up a world of wonder about the ancient past. It makes them realize that the history of life is filled with creatures more fantastic than any mythological beast. It is a gateway animal, inspiring the next generation of scientists, artists, and thinkers. Helicoprion also carries an important warning. Its extinction during the Great Dying is a stark reminder of how fragile life can be. It was a top predator, big, powerful, and successful. Yet it was wiped out by rapid climate change. This story from 252 million years ago has powerful relevance today, as our own planet faces environmental challenges caused by rising temperatures and changes in ocean chemistry. The story of Helicoprion isn't just about the past, it's a cautionary tale for the future. It shows us that even the mightiest creatures are not immune to the consequences of a global environmental crisis. Ultimately, learning about an animal like Helicoprion enriches our understanding of our own place in the universe. It connects us to the deep, vast timeline of Earth's history. It shows us that our world has been shaped and reshaped by incredible forces and has been home to countless amazing life forms. By studying these long-lost worlds, we gain a deeper appreciation for the beauty, strangeness, and resilience of life. Helicoprion is more than just a fossil. It's an invitation to imagine the impossible, to explore the unknown, and to cherish the incredible story of life on our planet. It's a story that's still being written, and we all have a part to play in it.